In this mathematics video, students will investigate and calculate best buys with and without digital technologies. I like drinking Coca-Cola. Sometimes when I want a six-pack of Coca-Cola, I go to different shops to see which has the best price. When I'm looking for the same product, it is really easy to compare prices because I'm simply looking at the price for the product, in this case, the six-pack of Coca-Cola. After going to 3 different shops, I compare the prices and choose the shop with the cheapest price for the six-pack of cola. When comparing products of different sizes and different prices, it's a little more complex. Many stores help us to determine the best price for different size products with different prices by giving us what they call the unit price, which is the price per certain size. So for example, for this rice, they give us the price per 100 grams so we can compare the prices of different products. In this example, the 5 kilogram bag of rice is cheaper than the 1 kilogram bag of rice. In this example, the 2.5 litre bottle of laundry detergent is cheaper than the 1.5 litre bottle of laundry detergent. So when we go to the stores, if we're comparing the same product, we just look at the different prices. Alternatively, we look at the unit pricing on the price tag. However, sometimes neither of these is an option. We then have to calculate the best buy ourselves. I love birthday parties. At a recent party, I was asked to bring along the Coca-Cola. At the supermarket, they sold the Coca-Cola in 6 packs, 10 packs, and 24 packs. Each pack had a different price, so I had to work out which was the best buy. The first step in calculating the best buy is to identify the known variables and unknown variables. In algebra, an unknown variable is called a pronoun. The known variables in this equation are the number of Coca-Cola cans in a pack and the total cost of the Coca-Cola pack. The unknown variable is the individual cost of a can of Coca-Cola. The second step is to move the unknown variables to one side of the equal sign and the known variables to the other. It is important to remember in mathematics, when one number moves from one side of the equal sign to another, it changes and becomes reversed. Once we have completed all three equations, we can see the box full of 24 cans of Coca-Cola is the best buy at $1.25 per can. Sometimes we've got to determine the best buy when a packet, for example, the jasmine rice, is of different sizes. The first step is to change the quantity to the same measure, in this case, kilograms to grams. Now that all three packets of rice are in the same metric measure, which is grams, we need to determine the lowest common denominator. The lowest common denominator that is common to all three measurements is 100 grams. So we will use 100 grams to determine best buy. We now need to reduce 2,000 grams, 1,000 grams and 500 grams down to 100 grams. To do this, we have to identify what we need to divide each number by. 2,000 grams needs to be divided by 20, 1,000 grams divided by 10, and 500 grams divided by 5. Now let's calculate the unit price for the 2 kilogram packet of rice. Now let's calculate the unit price for the 1 kilogram packet of rice. Now let's calculate the unit price for the 500 gram packet of rice. We now need to determine the best buy based on the unit price. The best buy is the 2 kilogram packet of jasmine rice because it is cheaper per 100 grams than the other two options. This video has been created by Capitalize Education. At Capitalize Education, we aim to support teachers with personalized learning.